In exercise 2.2c, we are asked to find the HCF of the following using index notation. HCF simply means the highest common factor. So we shall divide 1,800 and 6,000 repeatedly using their common factors. So this is 1,800 and 6,000. So 2 can divide, because the rule for divisibility by 2 is that the last digit must be an even number. So 2 can divide 1,800 900 times and can divide 6,000 3,000 times. 2 can still divide based on the same reason. 2 into 9 is 4 remainder 1. 2 into 10 is 5, into 0 is 0. 2 into 3 is 1, remainder 1. 2 into 10 is 5, into 0, 0, into 0, 0. 2 can still divide. 2 into 4 is 2 times. 2 into 5 is 2 times, remainder 1. 2 into 10 is 5 times. 2 into 1 it cannot. 2 into 15 is 7 times, remainder 1. 2 into 10 is 5 times, and 2 into 0 is 0. 2 can no longer divide because 5 is not a multiple. It's not an even number. So we test with 3. Can 3 divide? 3 can go into 225 because the rule for divisibility says that the sum of the digits in that number must be divisible by 3. And if you add 2 plus 2 is 4, 4 plus 5 is 9. 9 is a multiple of 3, meaning since 9 is a multiple of 3, 225 is also a multiple of 3. Same thing goes with to 750. 7 plus 5 plus 0 is 12. Since 12 is a multiple of 3, it therefore means that 750 is also a multiple of 3. So you divide by 3. 3 into 2 you cannot. 3 into 22 will go 7 times, remainder 1. 3 into 15 is 5 times. 3 into 7 is 2 times, remainder 1. 3 into 15 is 5. 3 into 0 is 0. Can 3 still divide? No, because the rules for divisibility have been violated by 250. So we therefore use the next, which is 5. Is 5 divisible? Yes, because the rule for divisibility by 5 says that the last digit must either be a 0 or a 5 or a multiple of 5. So this is met. So 5 can divide. 5 into 75. 5 into 7 is 1 times, remainder 2. 5 into 25 is 5 times. 5 into 25 is 5 and 0. 5 can still go. 5 into 15 is 3 times. 5 into 50 is 10. There is no other prime number that can divide 3 and 10 without a remainder. So we shall then look out for the HCF. The HCF is said to be the product of all the prime numbers that are being used, which is 2 times 2 times 2 times 3 times 5 times 5. So that the HCF of these two numbers is said to be equal to 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 25, so we have 24 times 25, 4 times 5 is 20, you write down 0 and carry 2, 5 times 2 is 10, plus 2 is 12, 2 times 4 is 8, and 2 times 2 is 4. So this gives us 10 carry 1, this is 5, 600. So our HCF is said to be 600, meaning that the highest common factor of 1,800 and 6,000 is said to be 600. That brings us to the end of today's class. In today's class, we have looked at HCF, which we refer to as the highest common factor. And in order for us to get the highest common factors of two numbers, I have given you about 4 different methods in achieving them. One of which we say is by prime factorization, another we say is by the use of diagrams. We have also looked at by the use of index notation. I also showed you the fourth method, which I said you list out the factors of each of the numbers, then you look out for the one that is common, and therefore the highest of them that are common gives you the prime factors. Thank you for being attentive in today's class. Kindly like my videos as you watch. While I recommend that you subscribe to my channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. You can also use the comment section to interact with me on areas that are still difficult for you to understand. While I recommend you share the link with your friends and families so that they can also benefit from our daily classes. Thank you and do have a nice day.